Let's start with the word algorithm. Where might you have heard the word algorithm before? Well, an algorithm is a set of instructions that a computer follows to solve a problem. But what has this got to do with maths? And why do we have to learn about them at all? Well, wouldn't it be great if we could get computers to solve the maths problems for us? I think most of us will say this is indeed a good thing. Well, we need to learn about algorithms and how to design them so that we can use and create them to allow computers to solve these difficult problems for us. But it's not just maths problems that algorithms can help us out with. Algorithms are used to solve problems in science, in engineering, even sports and art, economics, finance, business, politics. Algorithms are used all around the world to help us solve problems and to make our lives a better place. And you probably would have come across the word algorithms in social media as well. You may have heard that algorithms are used to show you what videos and content are popular or ones that you might find interesting and will engage with. Why do you think the word algorithm is being used here? Well, they're called algorithms because these social media sites and apps are following a set of instructions to figure out what videos you would want to watch and to engage with. Someone had to come up with these algorithms, that is, these instructions, and computers would follow them after giving them a lot of data to work with. So if you think about algorithms like a recipe to cook your favorite dish, well, the recipe wouldn't be very useful without ingredients, would it? So in the same way, algorithms are these set of instructions, but they need data in order to work well. Algorithms also have a certain type of structure and language. So we'll begin by using English type statements and then introduce you to a visual way of representing algorithms called flowcharts. Let's start with an example algorithm together, which is an algorithm to classify shapes. So you might think, well, why is that useful? Think about self-driving cars. Do you think an algorithm for classifying shapes would come in handy here for detecting the road signs that they may see on the streets? So you'll probably recognize a variety of different shapes that road signs come in, but we're going to start with a very simple algorithm to see if a shape is basically a rectangle or a square. Let's see how you do. Here is a shape. Is it a rectangle or a square? Hopefully you would have all said rectangle, but for right now, the answer isn't quite as important as the steps that you took to recognize that shape. So how did you reach your decision that that shape is a rectangle and not a square? In your books, write down the steps and any questions that you asked yourself in order to arrive at your answer. So those questions and steps that you wrote down, this is the algorithm that you used to work out whether the shape was a square or rectangle. So you've written down a basic algorithm for yourself. How is this different from an algorithm that a computer might follow? So unlike your algorithm, which was probably written in English or the language that you speak or think to yourself in, computer algorithms are represented in other ways. Sometimes computer algorithms are represented in a language called pseudocode. Sometimes computer algorithms are represented by diagrams. We're going to focus on representing algorithms in a type of diagram called flowcharts.